Welcome to Embedded, a show about the many aspects of engineering. I'm Alicia White alongside Christopher White, and this week our guest is Patrick Yuan of Planet Labs.
Hello.
Hi, Patrick.
Could you tell us about yourself?
Sure. I'm an electrical engineer, currently working at Planet Labs. We're a small satellite company. But before that, I've had some time playing with robots or toys that pretended they were robots, as well as some interesting radio hardware.
So I have a lot of questions about Planet because satellites and space and cool. And those of you out there listening may be like, Planet, when did I hear about them? They did do some advertising, gave away some t-shirts and whatnot in exchange for getting the word out about some open jobs. So that's where you might have heard of them from this show. But we're going to talk about these satellites themselves. Before we do that, I want to do lightning round. The idea is for you to give short answers. And then if we are on our best behavior, we won't ask you to explain them. Christopher, you want to go first?
Okay. Least favorite planet?
Ooh. Neptune seems pretty boring.
Most favorite extraterrestrial planet?
I think Mars is great. We've seen a lot of it. We explore. There's still robots moving around on Mars. It's got a lot going for it.
All right.
Wait, one word. Sorry.
No, that's fine.
Wait.
You've heard the show. We don't actually do that.
Engineering or managing?
Engineering.
Favorite processor of all time?
Not really decided. I don't care.
Huh.
Hardware or software?
Absolutely hardware.
Okay.
I was going to change that one up. I was going to ask if you would rather explain I squared C or versus SPI, or would you rather explain decoupling capacitors?
Coupling capacitors are also fun, I think.
Okay, so favorite fictional robot?
Definitely Wall-E.
Okay.
When you were young, what did you want to be when you grew up?
At different times, astronaut, firefighter, rock star, dinosaur.
You could almost combine three of those. Well, since you said dinosaur, should we bring back the dinosaurs?
Absolutely.
All right.
Hacking or making?
If I don't have to support it, hacking.
Is a mobile phone an embedded device?
Half of it is.
I think we're out.
Okay. What is a day in the life, a work day, like for you?
So depending on where in the development cycle we are, I might either be banging out schematics and layouts to add more capabilities to our satellites. I might have a prototype satellite that is doing exactly what we don't want it to do, and I'm stuck trying to figure out why. So that would be bench time with scopes and soldering onto precision equipment. Or I could be trying to read into data from satellites on orbit to figure out, again, why they're not necessarily doing what we think they should be doing.
So that sounds like two hardware tasks and a software task.
Yeah, that would be about right. It's when I started, we were a much smaller company. We were 60 or 70 people. So we did even more software stuff. There's very much cross-team work. Now we have a bit better separation into teams as far as responsibilities, but you still need to know a lot of what the people close to you are doing.
Okay, so we've talked about Planet, and you make satellites, and how are your satellites? What do they do? I mean, what is the real goal behind your satellites?
Right. The short story is we make shoebox-sized satellites. The dream is to take a picture of the Earth every day at 3-meter resolution. So every pixel on the picture would be 3 meters by 3 meters. And with this, you can see changes on across the planet at the scale of daily or weekly. We can watch environmental changes and farming and Maybe watch cars in parking lots, but nothing much more precise than that.
So how many satellites would you need in a constellation to actually achieve that?
We're actually working on getting our first constellation that can do full daily imaging, and that's a little bit over 100 satellites right now.
Okay. I guess if they're shoebox size, I mean, it's still amazing.
Yeah, so this is more of a swarm mentality instead of, you're building a beehive instead of an elephant.
Yeah, absolutely. And that's really the big change. One of the big changes we've done is we've gone from the one big satellite that you can't afford to let it fail to this group of 100 satellites that on the whole mostly don't fail and can then do better coverage of the Earth. Yeah.
So that's a really different mentality. I mean, we're so used to, if it goes into space, it must be perfect because it's so expensive to get it there. But for Planet, you have a more, I want to say agile.
Why?
Although
Why?
and I don't want to say breakable, but a faster mentality that it's okay to fail a little bit in certain ways.
We actually have something we call agile aerospace. I was just not going to deploy those words against you. But the idea was fail early, fail often, not fail completely, but run experiments. We call them tech demos. And just if we're going the slow way and making absolutely sure we trusted everything before we launched it, we probably still wouldn't have something in space. So it's try, see what doesn't work, see what does. Some of what we're doing, I mean, the idea is running 100 satellites. Nobody's done that, so it's not even something that, we run into new problems that nobody thought were going to come up. So between synchronizing satellites or just keeping track of all of them or keeping them all spaced out or just managing them. I mean, if you look at NASA, you've got dozens of people running one satellite 24/7. And I don't know if you've seen what salaries like in some places, but you can't pay dozens of people per satellite at 100 satellites. Right. But yes, it's a lot of run an experiment, be ready for parts of it to fail, take that risk and learn from it and go on.
So how many satellites did Planet have up when you started?
When I started, I was just about the 70th person, and I think we had just launched the 70th satellite. We had just delivered the 70th satellite to launch. Probably we were just delivering it, and those were the 26 that blew up. Yeah.
Right. There was a rocket that blew up a while ago.
Was that the SpaceX launch or the orbital launch?
It was orbital, the Antares out of Wallops.
Okay.
We actually figured that those satellites made it higher on the flight over to Wallops than they did on the rocket.
So how many satellites have you delivered now?
I think,
or how many do you have in the sky?
Currently in orbit is 30 or 40. We've had about as many deorbit, hit end of life, and just burn up in the atmosphere. We have another 20 some on the space station waiting to be deployed.
Okay, so you have satellites going up, and you have some getting ready to launch, and you have some that fall out of the sky because you don't put them. You put them up at the very top of the atmosphere, and there's drag, and they come down, right?
Yeah,
that's how they deorbit.
So part of it is that, they naturally deorbit. We can't get past that. Part of how we initially started getting up is it's relatively cheap to get to the space station, but that's the orbit that it's in. You're stuck with that, especially because they don't want you sending more propulsion to the space station. I don't think they want us to fail too quickly right inside the space station.
Right.
That'd be bad. Wait a minute. You don't have any proponent, Propellant.
Right.
So what the astronauts up there just like chuck them out?
They almost. We ship them up in deployers, which are basically spring-loaded tubes. It's not much more. Well, I mean, the people who make the deployers will tell you it's much more. I'll say it's not much more than an expensive space Nerf gun.
Come on, but space railgun sounds so much better.
Right,
but space Nerf gun is pretty good.
And they just put it out the space station, point it away from face, and let them go. And after that, we do have some of the normal spacecraft control stuff. You have reaction wheels and magnetotorquers, basically electromagnets to align with the Earth's magnetic sphere. But we do have a neat thing we do by turning the satellite to present different sides to the atmosphere, the little bit of atmosphere that there is. We can change how much drag it experiences and use that to space out our satellites for optimum imaging alignment.
Yeah, I was going to ask, how do you get a diverse set of orbits from basically hand tossing?
It's not really a diverse set of orbits. You're still stuck like along the same basic orbit. You just space out along the track.
Okay.
This is not something we invented. This has been theorized a lot, but I think we're the first ones to do it. We do have, if you look up Planet Labs paper, I think I can give you a link.
Yeah.
We have published a paper about how we do it if you're really interested in learning that.
Okay, but let me understand a little better. You have magneto things, and that's going to put you in line with the Earth's orbit, just because they're magnets, and that's how
with the magnetic field.
With the magnetic field, right? With the magnetic field, and like a compass.
Yeah.
And then you have a little wheel on the inside, and if it spins, that means you have angular momentum, which means inertia means something has to go the other way.
Right. The all of the torques, the sum of all the torques, the circular forces on the spacecraft have to be zero. So if you spin up a wheel going one way, the rest of the spacecraft will spin the other way.
Perpendicular of the first spin. Well, right hand rule. Yeah, we're all sitting here with our
we're all
thumbs
doing
and turning, and it's. But precession, look it up. It's a cool thing.
Right. And if you're ever at a really cool science museum, they'll let you sit on a spinny stool, spin up a wheel, and flip the wheel, and all of a sudden you'll start spinning on the stool without touching anything else.
It is a pretty magical, invisible thing, like magnets. It's weird. Okay, so you can spin your thing, but you can only spin it in one axis then? The satellite?
No, you have enough wheels to be able to.
Oh, okay.
Right.
So
if you'd played more Kerbal Space Program, you'd understand this.
Yeah. Okay. And then you have like a sharp side and a flat side. I mean, now I'm thinking about sailboats and you can go into the wind or you can go and. Yeah.
Right. It's not quite like sailboats. Because they also use their rudder and the keel and the force of the water. If you think more if you look at pictures of our satellites, we have 7 solar panels that we use to collect light, and they all point the same way. So if you do the solar panels kind of into the wind broadside, you've got, say, 7 panels worth of drag. And then if you turn the satellite so that they're going edge on, you only have the one panel that's the body of the satellite. And just the difference between the drag of the two lets you space out the orbit on track.
But don't you need to have the solar panel pointing towards the sun all the time?
Enough of the time. And we have batteries. It's a good thing we don't have it we don't need it all the time because we go into eclipse half the time.
Well, yeah, but you don't even need it half the time then.
Right.
Efficiency's cool.
It's yeah.
Okay, so that's how they move, and that's how they get to different orbits. But what can you tell us what's inside? Can you tell us anything about what's inside? And we haven't actually said that the names are Dove.
Right.
Oh,
Yeah.
I should say that.
Yeah. Okay. We like to call them doves. This was when the founders were getting together to figure out what they were going to call it and give the project a code name. So we do imaging satellites, and a lot of traditional imaging satellites, to appeal to certain customers, they would give them very aggressive names. They would be Eagle or Hawk or Kestrel One and
Gambit.
And our founders were thinking, we want these to help people and to be peaceful and friendly, so we call them doves.
I seem to recall that when I visited your factory, they did mention space hippies.
I don't know if that's official, but I would describe our founders as self-confessed space hippies. Yes.
Okay, so they're doves, and they're gonna make the world a better cooing place. But what's inside of them?
Right. Again, what's inside?
Not birds.
Not.
Hey, they tweet. I've heard them tweet.
Oh, he's clamming up. Maybe
Can neither confirm nor
birds.
deny. Right. So can't get into very specific details, but interesting things we've done include everything that we don't do space hardware. Traditionally, you can get space hardware. It's 20 years out of date because that is the stuff that has already flown. In the space industry, flight heritage is gold.
But space hardening is hard. I mean, I read about how to do that, and you have cosmic rays and voting and temperature swings that are just insane. It's not just that you have to go from really, really, really hot to really, really cold. You have to do it fast.
Right. And you don't have the air to just sink your heat out into.
Yeah.
It's not especially easy, but it turns out at our altitude, we're still mostly coupled to the atmosphere. Our electronics tend to be industrial grade temperature ranges, and that covers us.
So industrial is wider range the consumer, but not even sometimes automotive is outside of industrial.
Right. Oh, if we could get automotive, that's even better.
Yeah. Okay.
But I want to say usually you'll see specs like minus 20 to plus 80C. That kind of stuff would mostly take care of us.
Cool.
And it's compared to space grade, it's cheap.
Oh, yeah.
The salespeople come in and they get all excited to sell us a chip. Like, hey, we want to show you this new FPGA. It's space ready. And we look at it and go, like, there's no way we're paying you
10,000 gates.
Right. And we're not paying you a tenth of that price. This is not happening.
Well, I remember reading not that long ago, right? Well, I guess it was a while ago now, when the shuttle was decommissioned, they were talking about some of the hardware in there. It was like, oh, and it's got, the latest 386 space hardened CPUs in the flight controllers. And
right. I feel like I heard that they were trying to find new old stock of 386s while the shuttle was still flying.
You'd have to. I mean, they're not going to make anymore, but okay. So you have off-the-shelf parts.
Yeah.
Because they can.
Because it seems to mostly work.
So how long are the systems up there?
For the most part, so lately the last couple years, we've been doing about 18 months to 24 months before we deorbit.
And then do you intentionally deorbit and then use the solar panels to stop yourselves and then you'll fall?
We don't. I mean, we could, but no, that's just the orbit degrades. There's enough atmosphere to do that to us. That's also handy because if we lose control, things just kind of tend to fall out of the sky and not go bumping into other satellites. But no, there's always something more we can learn from a satellite, even as satellites in the past have lost imaging capability or just imaging value because this is, 3-year-old tech, which is traditionally in space not very old, but I mean, your 3-year-old iPhone is nowhere near what your new iPhone is. And that's kind of the model we're trying to follow. So as it becomes less valuable, we might try other experiments on it. How hard can we push the power system? How well can we control it? Type of questions.
So you punish them once they get too old.
No.
Well, and you must have failures that are not total failures. Like, oh, our imaging system's down. What can we do with this? Do you have that happen occasionally? Where you can just, okay, this one's kind of dead, but we can play around with it.
Right. It's more of a, it's not useful in this manner anymore. Let's take risks on it that we don't want to take. So if we want to upgrade the onboard software, which always feels a little iffy, right? I mean, it feels a little iffy when you can ask your customer to ship it back to you if you break it.
Yeah.
We can try it on a satellite that has no imaging value anymore. Or even if you just want to run experiments that interfere with imaging, then you don't run it on the ones that can take valuable pictures.
No, instead you can use those to find out if their radios will burn up if you push them too hard.
Mm-hmm. So far, no.
That's cool. Okay, so when they fail, how do they fail? Do you have any lessons learned from time and space that you can talk about?
I don't think I can really go into specifics, unfortunately.
Okay, that's fair. Well, actually, let me ask you a question that may not be what's holding you back. But when I talk to people about space and I want to get them on the show, ITAR is what they often talk about. Mm-hmm. What is ITAR?
I think it stands for International Traffic in Arms Regulation. Basically a set of laws and treaties that the U.S. leads on that are meant to stop other countries and especially rogue agents from having access to weapons and advanced technology that can be used in weapons. Everything nuclear power related, everything related to fast planes, to very precise this or that. Anyway.
And encryption was under that at one time, or still is, or...
Yeah, I've had to fill out ITAR paperwork because I had a device that had encryption on it that we wanted to send to a friendly country. But still, since encryption is a munition...
Right.
Inexplicably, I suppose. Yeah.
Yeah, well, the interesting thing they did about encryption back in the 90s is they just printed out the source code in books, and then it became free speech, so they could ship the books and retype them from another country. Which, I mean, nobody got arrested for that, so I guess it worked. But space, the majority of rocket systems, my understanding is they are ICBMs that just... took off the M part.
Yeah.
Intercontinental ballistic missiles.
Yeah. They just changed them so that they don't come back anymore. And that's how you launch satellites.
BR rockets. Yeah.
But so the government's a little uncomfortable about random people finding out about rockets. And for similar reasons, everything that was a satellite was ITAR for a while. Recently, maybe a year and a half ago, it changed to most of satellite stuff got changed to EAR, which is a more commerce-related export restriction. It's still export restricted, but it's now, I think, Department of Commerce instead of Department of State.
And they want you to sell things. The Department of State doesn't want you to sell anything.
Right, something like that. But it comes out of all this, what falls out is if something hasn't been published, we can't describe it because that is now export if you describe technology.
Okay.
So like your way of changing the Dove's orbit, is it that one of those things that was tough to get published?
I don't know about the details behind it. I know as far as the publishing, I do know that idea had been published before. Like I said, we weren't the first ones to think of it. I'm sure that they got approval. Like we're not quite that rogue.
Well, and most things have already been written up in science fiction at some point.
Yeah, exactly. This is the sort of thing where science fiction leads the way.
So you guys have a lot of satellites and you're planning for more. You always hear about, certain orbits being crowded and lots of debris. And now we're worried about space station running into micro paint particles and things. How does that work with things that are active? I mean, is there a limit? Okay, we're full of satellites. Does like NASA track all of these on your behalf? Or is somebody watching the?
Everybody kind of pitches in.
Okay.
The important group in the U.S. is called JSPOC, Joint Space Command, and they track things with radar. We also have more precise locating on our satellites specifically so that we can actually point at them accurately for radio reasons, and so we can predict where they will be in orbit. And satellites are just, traditionally, they're so expensive that everybody just kind of gives each other's heads up and like, hey, it looks like in a couple days we're going to come within 20 kilometers of each other. If we move a little bit right now, we'll be like 60 kilometers apart. And that sounds safer, right? Right. Yeah, let's do that.
Okay.
Well, that sounds safer. I mean, because 60 kilometers sounds like a long way, but these are trucking. I mean, they're going fast. So if there were humans in there, that would be, I mean, less than a second of reaction time to move out of each other's way. These probably don't have to, but okay.
Right. Well, it's also, orbits are pretty easy to predict over the next few hours at least, sometimes a few days. Like when something's moving, it tends to stay moving in the same direction. There's no wind buffeting them and there's no potholes to dodge, like if you think of the highway.
Yeah, there's only the slow degradation, which is also pretty predictable.
Mm-hmm.
The CubeSats are smaller than most other satellites. How big are they when they're deployed? You said shoebox when they're launched, but with those...
Right. So a CubeSat standard is you ship inside a 10 centimeter by 10 centimeter by 10 centimeter cube. That's about 2.5 inches a side. No, 3 inches a side. 4 inches a side. 4 inches a side. And we
remember that thing with Mars and the metric version?
Yeah. Well, there's and we ship in a 3U configuration, which is, as you would guess, 3 CubeSats in a row, or the size for 3 would be us, which is 30 by 10 by 10 centimeters. And once we're deployed, we let out 3 solar panels from each side, which brings us to 7 solar panels along one side, which will be 70 by 30 centimeters. And our main body is still that 10 by 10 by 30.
Cool. Okay.
So it's a shoebox with wings. There's lots of photos of them nowadays, of ours specifically. So if you can get the
check the internet. I'm
Right.
sure it will help people. So I mentioned CubeSats because they're more becoming within the grasp of hobbyists.
Mm-hmm.
And what could you tell people who are considering doing satellite things? What advice do you have for them?
The first thing to realize, I think, is it's going to take a long time, especially even if you have money for launches. You'll sign up for a launch and they'll say, yes, we're absolutely going to launch in a year. And 3 years later, they'll be like, hey, do you still have that satellite? Because the launch is coming up.
Really?
Yeah, well, if you're a CubeSat, you're not the main customer. You're a secondary customer. And if the main customer who's paying for 95% of that launch wants to delay by a year, then you delay your launch by a year. So it's going to take a long time. It's going to take a long time to get your satellite working in the first place. And just, I guess, try not to do anything you don't have to, because those are all things that could go wrong. So if you're really interested in measuring space weather, don't try and invent your own radio and power system if you can find somebody else's radio and power system and use it.
This is my advice for startups. Don't invent anything that you don't have to. Mm-hmm. You can always cost reduce later if necessary. Although once it's in space, I guess you're cost reducing the second one.
Right. But I mean, if what you're really interested in is space power systems, then yeah, go ahead and invent that.
That makes a lot of sense. And now there are enough things to find off the shelf?
There are definitely companies that will sell you CubeSat related things. I'm, to be honest, haven't really been following what's being published. I know We Planet Labs are publishing, we're open sourcing our basic low speed in this case is, dial-up speeds, which is still not bad for something 400 kilometers away at 7 kilometers a second. But the in space. The nice thing is we've proven it works. We use it every day, many, many times. So if you don't want to make space radios, you just want to talk to spacecraft, then there's a little heads up.
When does that happen? Does it already happen?
No, SmallSat this summer.
Okay.
Yes. We'll
find a link.
Yeah, we'll provide links when we can.
Yeah. That's pretty cool. So if Planet is, how are they going to make money if they're giving away their hardware ideas?
They're not giving away the data.
That's right.
Yes, but now he gets to tell us about that because it's kind of cool.
I ruined the segue.
You totally, yes. You just stomped all over my segue.
So for one, we're only giving away some of our hardware ideas. The slow radio. You can imagine we're not downloading pictures over dial-up anymore.
The warp drive is completely off limits.
Can neither confirm nor deny. But yeah, we're actually a company that sells imagery. If you thought of us as a factory selling widgets, what I work on is the factory machines. The satellites just create pictures. Well, take pictures. So imagery is what we're selling. 3-meter pixel, whole Earth every day. You want to see changes in environment or farming. There's already a whole lot of people interested in Earth observation data. So hopefully they're also interested in giving us money.
So the images are all normal optical, or do you do IR and some other things?
We do an RGB sensor. So red, green, blue, basically what you expect in a personal camera, a little bit higher tech for us, but surprisingly not as much as you would think. We've also started doing near IR. So not thermal IR, but good enough that you can pick out vegetation really well once you can do IR.
And so one of the applications for you has been illegal deforestation, not illegal foresting, because that's not a thing.
That's a different thing. That happens a lot around here a lot, but...
Right. Deforestation. So what are the other applications?
Specific applications are just watching in general farm production in large areas. One dream that people have always had with satellites is to be able to calculate how much corn is grown around the world today and tomorrow and when it'll hit market. How much food we have to feed how many people. But we've also, we follow large groups of people moving. So large, population movements is what I meant to say. To the extent of we have imagery of growing refugee camps. We have...
have you seen the pilgrimage to Mecca?
We have... I think that's an ongoing thing. There's basically a constant stream, is my understanding.
Oh, there is, but there's the big one, the Hajj.
Yes.
We should check later. We've definitely got photos of Mecca. Yeah, that'd be an interesting one.
That goes to millions of people fairly quickly. Yeah.
Right.
Hey, we can look at Maker Faire this weekend.
If we millions of people.
Ooh. I wonder if we've got anything overhead. We don't currently have full daily imaging, so we just kind of have to wait for the orbits to line up.
But that's the thing. Once you have that,
right.
you could spend your entire day just brainstorming. Okay, we could look at this. And we could look at this.
Well, yeah, because as a farmer, you could, if you really had consistent daily data, you could use that to help control how much water you're
Right.
using. And I did see you have a great Planet has a great Twitter feed where they show the pictures sometimes, and I'm constantly fascinated. Illegal gold mining.
Right. Yeah, that was right at the one we found was right at the edge of a national park, I believe, down in Ecuador. I feel like that's wrong.
I have a link here somewhere.
But the point was, it was right at the edge of a national park, and the rangers, the park rangers, whoever's enforcing, don't always have a chance to basically walk the whole park. But we could just look at the changes over a month, say, and it's like, oh, there's definitely people gold mining. This is definitely harmful to the environment, and it's definitely illegal there. We do the same for logging. We do the same. I think this comes out of a bit of a space hippie appeal to where we can see the environment being abused. We'll flag it.
So how much processing do you do?
So that's the other end of the building. I don't really know the technical details too much. We do have to color correction. We have to do what's called orthorectification, where we have a pretty good idea of where the picture we took is, but not exactly where. So we basically line it up with how the Earth is supposed to look.
How do you know where they are, sort of? I mean, do you get GPS on the satellites? That seems weird.
I don't think so.
It doesn't seem right, does it?
This is interesting. Why doesn't it seem right?
Well, I mean, the GPS satellites would have to be quite a bit higher than your satellites for you to be able to get GPS. I suppose you could get GPS from the ground, sort of. I mean,
so
I feel like this is an interview question.
that's why I was interested. I honestly don't know if the GPS satellites are much higher or not, but when you're doing GPS, you're finding the intersection of the distances from a number of satellites.
Time difference of arrival.
Yeah.
Yeah.
And is there any reason that won't work 400 kilometers higher than we are right now?
Well, I guess part of my mental image of space is there's this eggshell around the Earth, and that's where all the satellites are. And so if you were in plane or in concentric sphere with the GPS satellites, then you wouldn't be able to hear them. They would be pointed down and you would be pointed down. And
so
but
GPS
probably
satellites,
GPS is higher, isn't it?
They're at half geosynchronous. They're at 12,000 miles.
Oh, so
they're way above. But
you can just pop in a GPS receiver.
But I guarantee you it will not work.
Why?
Because the U.S. military makes things not work when you're in space because they don't want you to be using them to launch missiles at people.
And now I feel like I have many questions for Patrick that we should just skip right over.
But getting back to the original question, the original question was, how do we know roughly where it is? And again, if we go back to orbits are pretty predictable. And if we have an idea of time, then we have an idea of what we're directly above.
And you probably get time from GPS, although I won't ask you that.
Or we just keep
Ship
track. You have an oscillator. And then you just do your best to point straight down.
Yeah, that makes sense. Okay, so there is some data that people can play with.
Absolutely. There's some data that I would love people to play with. You're talking about Open California, right?
Yes.
Yes. Okay. We want to make a lot of data available to a lot of people. And the first step for that is called Open California. And it's all of our imagery, uncensored, unlimited, of California that's more than 2 weeks old. Available, Creative Commons, attribution, share alike. Basically, if you do something with it, tell people that you got it from us, and yeah.
And so if I want to go look at the wine harvest last year, I could.
Right.
And if I want to go look at national parks and see how glaciers are doing, I can as long as it's in California, which sort of limits my options. But I can go, okay, so how do I do this?
I'll send you a link, of course, and you just sign up. And as a developer, you sign up, tell us what you want to do with the data, and we give you an API key, and you start downloading images. We have a published API that you can hit based on time and location. I use it similarly to pull up forest fire data so that we can see before and after of wildfires.
So I want to ask more about fires, especially the ones happening in Canada. But before we do that, I want to still the California data. Mm-hmm. I can get as much as I want.
I think so.
And isn't it expensive to you to host this much data?
I'm not sure. I think it's
all right. The internet's free.
Yeah, mostly. Maybe you'll make a really good product and that'll make it worth you paying us. I think that's kind of the idea, right? Well,
and it's a good demonstration of what you can do. So do you do hackathons around it? Not yet.
We did one at least.
I think you could have a hackathon with this and some of the open government things and just all kinds of stuff.
Yeah, we've done at least one. I think it was a Lesbians Who Tech meetup that was hosted at our office, and there were a few things that came out of that. One was again, forest fires. So forest fires are great because, well, no, they're not great. I'm going to rephrase that. Forest fires are exciting because they are change on the physical scale and time scale that matches our data very well. And one thing that we're really excited to drive home is the time axis on our data. And the fact that if you were scheduling these satellites, you don't get to say, there's going to be a forest fire next week. I want an image this week as a baseline.
Well, normally.
So long as you're not the evil genius.
You could also, the way we go sometimes, you could just image all of California and be like, yeah, statistically.
Exactly. September, we'll just be...
But we have it's a bit of a rewind almost. The more salesy people will call it time travel. But it's come in handy when we have just unpredictable disasters where you would have the earthquake in Ecuador, the earthquake in Nepal maybe a year ago. We were able to just say, oh, here's what Nepal looked like a month ago.
That would be really, really helpful. All kinds of ways. But forest fires, I can see how they would be interesting to look at. And you can say how much devastation there is, but why are they interesting? Other than the amount of fire? What information are you getting?
It's a rapid change of a vast area, so it seems like that would be one of the bigger...
Right. So for me personally, why they're interesting is just they show up well. They are at the right time scale and physical scale. As far as interesting for applications, they're...
Well, I'm thinking prevention or getting the data today that shows something about where the fire will be going. Earthquakes, I can see how getting the data today may show you where there are pockets of people, if you could use it to that granularity.
The other part about earthquakes, actually, if you think of Haiti had a really rough one a while ago. And one of the biggest problems, as I understand it, that relief efforts had going in is Haiti is not an especially rich country. And they'd go in and there was a building that had collapsed and they didn't know if it had collapsed during the earthquake or 2 years before the earthquake. And to not know that, and to not know if you're about to spend this critical 4 days trying to rescue people from an abandoned building and ignore the one that has all the people is extremely heartbreaking. So to be able to see what was collapsed the day before the earthquake.
And so you have these before and after pictures, and usually there are bars and a little thing you mouse over to grip, and then you can see this is before and this is after, and that's really amazing. And but I'm still having trouble with application with fires. Should we just go on because fires are pretty, and that's the good part of them?
Yeah, maybe.
Okay. Sorry.
No, it's fine. That's just I'm sure somebody has a good sense of application. I sure hope somebody does.
Well, wind direction tells you, and smoke plumes will give you information. I'm sure there's
and
cool
you can look at burn patterns and figure out, okay, well, next year where are we probably in trouble? You can, look at historical fires and compare those to other areas that are looking dicey. I think there's a lot of stuff you can do.
Well, then I can see how you might be able to figure out which areas are likely to burn tomorrow based on their vegetation. And then you go fight the fire. You either sacrifice those areas or you fight for those areas, but now you know which ones are the most dangerous.
Actually, with Near IR, we can do a good sense of vegetation health, which would, I expect, I'm not a scientist on this, but I expect it's a good hint of where it's going to burn better.
So there's definitely, yes. Okay, thank you. Sorry, I'm done with fires. Can we talk about what operating system the devs run?
I don't think so.
Okay, because
Windows XP.
No, it's not.
No.
Yeah, I was talking to a satellite fan, and he knew what it was. But let's just go on. Are there any surprising findings from the satellites that you can tell us about? Things that weren't expected?
About space or about Earth?
Either.
So many options. It's like a smorgasbord.
So about this group or about everything that's not that place? Was my question. So I can tell you, so there's a lot of things that we were worried about that we ended up not really needing to be worried about. So if we go back to radiation hardening, and that's something everybody tells you need, and I would definitely like it if I were in a spacecraft, no matter how safe they tell you it is.
Yeah.
So we used to watch space weather, and we have our operators, 4 operators right now for the entire constellation, watching space weather and like getting warnings that the sun's very active. And, you see those scare articles in the news every couple of years, like, oh, a big solar flare, we might lose all of satellites. And we used to put the satellites to sleep for that. And then it turns out it just didn't really affect us. Not that we could notice, at least. So we just kind of plow through whatever space weather gets thrown at us now. And it works.
Well, given your philosophy for how these work, it will work until it doesn't. And then you will learn your lesson, put up some different hardware or change your behavior so that you close them down when the weather is that bad or worse.
Right. And the idea, of course, is shutting them down doesn't, because we're worried about errant bit flips that send us running through the wrong part of an operating system or start, overwriting data that is controlling how we're pointing or something like that.
You don't even use the super, R versions of the ARM processors that have redundancy built in, do you?
No. Again, just no space hardware. We do our best to check everything, maybe check some it twice, have some very safe fallbacks, make sure you boot into a very reliable subsystem. And basically there's more than one microcontroller on board, and they can all rewrite each other. So if you lose one, you just rewrite it from another one. But we, in keeping with our take risks attitude, we don't have any redundancies.
That's exciting.
Well, the redundancies in the fleet.
Right, exactly that.
So how much do the satellites change between launches?
a huge amount. We when I joined, we were launching Build 9, and we have just deployed Build 13, which is 4 good generations in between.
When did you start?
2 years ago. Yeah. So we might change our power system, or we might try different sensors. So far, they've all been improvements. But yeah, it's a lot about learning what you can from the previous builds so that you can make better ones next.
Do you have any plans you can tell us about changing the size of the satellite?
No, I think CubeSats are working pretty well. It's cheap to get, well, relatively, again, it's cheap to get in orbit when you're on a specific, a standard shape.
Yeah. And it made me think about how at ShotSpotter, our hardware cost one thing, and then putting it on a building cost another, such that was pretty expensive. And sending anybody out to play with it was very expensive. And so we built our hardware different, knowing the reliability. And when you add a launch in there, but then we go back to the redundancy is in the fleet.
Right. And it would cost us fairly more than it would cost ShotSpotter to send somebody out to work on the hardware. I've volunteered, but so far, no takers.
Yeah, keep trying. I'm sure any day now.
So it seems like there's a lot of startups or small companies or non-NASA entities, kind of jumping into space. And you guys, and SpaceX is obviously a lot larger, but do you feel a kind of camaraderie with companies like that and SpaceX that, yes, we're taking I don't want to say Silicon Valley, but taking a standard tech industry approach to space where that hasn't been done before?
Right. The word that space people like to use is new space,
okay,
as opposed to old space, I guess.
Old, yucky, smelly space.
Right. There's definitely, I would describe it as camaraderie. I mean, there's enough exciting things to do that we feel like, trying to do the same thing as somebody else, but better it's foolish. I mean, you could also decide you want to put RGB cameras up there at 3-meter resolution for daily imagery, and but why would you go into somewhere where there's a direct competitor if you can take basically the same thing and say, we're doing these other imaging bands that these very specific narrowband sensors that are valuable to different customers, and now you have no competitors. So there's a great camaraderie, and we definitely cheer for all of them, especially the rocket companies, because we'll take any rockets that, man.
Planet's still hiring, aren't they?
Yes, always.
You had a lot of openings. I think the embedded software one is not filled, and there were a lot, actually. Yeah,
so for getting close to embedded people, there's also test engineers, which is go work designing the tests and working with the satellites in the manufacturing area. That's a lot of embedded / a little bit of EE / test and reliability knowledge. And then as you move kind of further from satellites, if the data part is what's most interesting to you, always need data product people. That's more of a image processing, ranging out to web development web development for the tools that make us money. So I can't say just that.
And then there's the marketing people,
Right. Well,
no, I'm not going to get
a lot of your listeners looking for marketing jobs.
So when you're doing manufacturing, I see these images of the big guys making their 4-story satellites, and they're in these clean rooms, and they're all wearing. That's not how your manufacturing looks, right? Because you don't need to do that,
right? Well,
I'm sure
I'm sure some people should do that, but okay. we have a clean-ish room, we call it, and definitely compared to the big scientific satellites, I've I know people who've been on tours to those and you're like, hey, can I get a picture by the satellite? And they're like, sir, please don't go within 6 feet of the satellite. So us on the end, those are people in big bunny suits, and you go through the puffer room to blow all the dust off you first, because humans are really dirty. But us, we put on a jacket and an ESD strap and gloves, because oils from your hands are the worst thing you could do. But other than that, yeah, just come on by. And we walk in and out of the clean room all the time. We also, I mean, the big scientific ones, you're building one satellite.
It's $1 billion, and please don't break it.
And us, we're building, well, once you're building, say, 100, you may as well build 110 and just count on breaking 10 of those, or 120, break 10 and send 10 of them to the development people so you can have a live satellite to play with. So we can be a little more cavalier in our manufacturing.
So what you're saying is you have extras.
That's what I heard. We should have asked for samples.
Ooh. But we do have because I'm upstairs with the hardware and I see our people coming through and giving tours every once in a while. Our CEO likes to talk about like, oh, I like playing a game here. Let's play a game as we go through the development area, because we're not NASA. So let's play Count the Satellite. Like, oh, there's a satellite on a desk. There's a satellite on a desk. You know, when I needed to test thermal capabilities of a part, I would just take a satellite and run it under the hot air and then the cold air, and just think, well, just make sure you don't accidentally fly this one because we put our grubby hands on it.
Have you ever licked a satellite?
What?
Oh, come on.
Can neither confirm nor deny. Of course I have. I have not. Definitely no. If anybody's listening, no, I have not licked anything. Nothing that went to space. No, absolutely not.
Yeah. Okay. So art. There is art on the satellites.
Yeah.
Tell us about how art and Planet Labs works together, other than your incredibly beautiful pictures.
We decided. Well, this was long before I joined. It was decided that we should have an artist in residence. And that was somebody who we would sponsor to some small degree. So it's not a full-time job, but a small residency doing art for us to help inspire us, to help kind of remind us that the whole world isn't white walls and black carpet. And I mean, we had this opportunity for it. So we ran with it. From our first artist in residence, we have an art director now who has, largest number of art installations in space, I guess. If we just like making up new records, so that's one. So he has led putting art on all of our satellites on places that usually are useless. So let's just draw on it.
Back of the solar panels and whatnot?
Yeah, back of the solar panels, the sides of the satellite that just, the sides of the structure. We have little drawings of doves on our antenna where we can afford to. Yeah.
That may be better than just licking it.
Well, being able to sign it is absolutely, it's something. We have special space markers that we've been guaranteed are not going to outgas and fog up our mirror, because that would be an expensive.
That would be bad.
That would be an expensive mistake.
So the markers are the one space hardware you invested in,
right? I guess. Yeah. Well, we do have space markers and a lot of space tape.
Is space tape different than Kapton tape?
It's probably just Kapton tape that costs twice as much because it's space tape. No, it's Kapton tape, but gold foil tape. A couple different foils, but a lot of it holding satellites in general together.
I always suspected it was all made of tape. I guess, does duct tape work in space?
I think it would work.
I mean, why wouldn't it?
Right. I mean, I think it would.
You should try it. Let us know.
This does seem like the sort of technical experiment you were talking about.
Right. Can we replace Kapton with duct tape? You can. So NASA has definitely done huge amounts of studies about what does and doesn't outgas. So that's our problem, right? In a hard vacuum that is space, a lot of things that on Earth don't outgas, or you don't think of outgassing. But by the way, anything you can smell is clearly outgassing.
And you can smell duct tape, so it's definitely
Right.
outgassing.
Right. So if it outgasses near our satellite, then you just have these atoms of gas looking for something to deposit onto. And if it's our optics, then that becomes a much less useful satellite.
Well, I think we're about out of time. Chris, do you have any last questions?
I don't. I threw every question I had in there.
Okay. Patrick, do you have any thoughts you'd like to leave us with?
I do have one final thought. I came ready for this one. I have that art director was leading a learn how to draw class for engineers. And he gave the advice that has stuck with me since. That is just simply give yourself permission to make mistakes.
That seems like a very good philosophy. My guest has been Patrick Yon, electrical engineer at Planet Labs. Thank you so much for being here.
Oh, thanks for hosting.
Thank you also to Christopher for producing and co-hosting. And of course, thank you for listening. Please check out our blog and newsletter. You can find it all at embedded.fm, along with the contact link if you'd like to say hello. And a final thought to tide you over to next week. Wow, I have such good ones this week. Okay. How about from Yuri Gagarin? Because that seems sort of appropriate. Rays were blazing through the atmosphere of the Earth. The horizon became bright orange, gradually passing into all the colors of the rainbow, from light blue to dark blue, to violet and then to black. What an indescribable gamut of colors. Embedded FM is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive any revenue from them. At this time, our sole sponsor remains Logical Elegance.